This is a 20-minute long presentation which explains what we know and what we don't know about the development of AS and A-levels in mathematics and further mathematics. It's an update of the presentation posted in April 2015. The first half of this presentation is mostly new information, with the previously given information about content coming in the second half. This presentation is about all new A-level maths specifications. The MEI website has a page with a lot more information and support for September 2017. Down to slide 21 is new information. From slide 22 onwards is a repeat of a presentation uploaded in April 2015. Maths and further maths will be ready for first teaching in September 2017. One reason for the delay has been so Ofqual can do some more work on how to assess problem solving in A-level maths exams. Ofqual is considering whether A-level maths exams should be available in June 2018 after 1 year of teaching. This is to cater for schools and colleges who enter some students for A-level maths in year 12 and further maths in year 13. The table shows how this fits with resit opportunities for the current modular qualifications as they come to an end. Exam boards are expected to submit their draft specifications to Ofqual in early June 2016. At that time, they will put draft specifications and exam papers on their websites. These will not yet be accredited, and it may be wise to delay making any decisions until some time later. The experience of the 2015 and 2016 A-levels is that subjects much less complex than mathematics and further mathematics take several attempts to be accredited. Although it's possible that an exam board specification might be approved by September 2016, it is much more likely to be nearer Christmas or even early in 2017. As we learn more about the reform and its consequences for teachers, you can keep up to date on the MEI website. Modules are disappearing. Students who are taking the full A-level can choose to take AS at the end of year 12 if they wish to, or they can choose not to. The AS marks don't count towards the A-level, and all the content of the A-level is assessed in exams at the end. It's a real challenge to increase the amount of problem solving, but not make the exams any harder. So, what do we know? We know the content for A-level maths. All A-level maths syllabuses will have the same content, about 2/3 pure plus some mechanics and some statistics. Half the content of A-level further maths will be the same for all specs, and the other half will be options. There's more about content in the second half of this presentation. We also know that there won't be any coursework in any of the specs. Ofqual has consulted about some of these issues, so we do know what they plan to do, even though the final decisions have not been made yet. The next few slides say more about Ofqual's proposals. Most of the new A-levels in other subjects are turning out to have a total of 6 hours of exams, often spread over 3 papers. For AS, it's often 2 papers, totaling 3 hours. An exam board might choose to have some non-calculator assessment, but they don't have to. You can find the formulas which have to be learned on the Ofqual consultation page. There are slightly more than in the current A-levels. Assessment objectives and their weightings tell you how many marks in the exams must be awarded for straightforward technique questions, how many for problem solving, and so on. The first assessment objective is about standard techniques. The proposal is that there are more marks for this in AS than in A-level. The second assessment objective is about mathematical reasoning. Improving the way in which students communicate their maths is one of the intentions of the reform, and it may be that mark schemes will be a little bit more specific about the need for well set out reasoning. The third assessment objective has separate strands for problem solving and for modelling. Some sample questions are included later in this presentation. Some flexibility is allowed in the proportions for further maths, so that different options can be assessed sensibly. More detail about the assessment objectives can be found on the Ofqual website. In the spring and early summer, a working group met with Ofqual to make some recommendations. Their report can be read online. They came up with some attributes of problem-solving questions. Such a question doesn't have to have all of those attributes. There are 3 examples of problem-solving questions on the next 3 slides. It must be stressed that these questions have not been through the rigorous checking procedures which exam boards use before a question is set on a live paper. The maths in this question is not hard, it can be done with just GCSE maths, but you do have to think about how to go about it, and there are several different methods. It doesn't matter which one candidates choose. It's important to stress that not all questions will look like this. There will be plenty of questions that look just like A-level questions do now. This question could easily be on current papers. It is problem solving because candidates have to choose which method to use, will probably use a graph as well as algebra, and have more than one step to carry out. So today's students do solve problems, but tomorrow's students will probably have to be a little better at it. This is perhaps a more challenging question because it's more open-ended. There's more than one right answer to the first part, and candidates have to reason in the second part. There are another 3 examples in the working group report on the Ofqual website. Modelling is about using mathematics to solve a real-world problem. Usually, some simplifying assumptions have to be made to turn the real-world problem into mathematics. In Part A, the candidate has to make several simplifying assumptions. For example, that the block drops vertically, that it can be considered as a particle, that there is no air resistance, and that there's no water in the shaft. One of these assumptions is questioned in Part C. The answer to Part B is so large that air resistance must come into play, which means that the answer to Part A is likely to be an overestimate. Another possible reason is that sound takes time to travel up the shaft. This could be part of a further maths question. Part A of the question asks candidates to give reasons why the Poisson distribution might be a suitable model in these circumstances. The rest of the question uses this model. Modelling is not limited to mechanics and statistics. It could arise in pure maths, for example in a differential equations question or a graphs question. One of the new requirements for AS and A-level mathematics is that students become familiar with a large data set during their course. The slide has a quote from the DFE content for AS and A-level maths. The idea is that some aspects of the statistics part of A-level maths are learned and practiced in the context of real data, with the data set large enough to need a spreadsheet to handle it. Statistics is the study and interpretation of real data to answer a question or come to a conclusion. It's no longer about knowing the formula for calculating a statistic when the technology will do that for you. The idea is that the large dataset is not something extra which you do after you've learned the statistical techniques you need to know. It's a context in which you learn them. In the exam, candidates will not have a computer, nor all the data from the large dataset, but they will be expected to be familiar with the contexts they have been studying. So, if students have been using data about health in different countries, a question in the exam might use the phrase physician density without explaining it. It might assume that the candidates are familiar with the idea that, say, there might be a positive correlation between physician density and life expectancy, and ask candidates to interpret some data or diagrams in this context. So we know that the content is fixed for maths, with 2/3 of it pure. How does it compare with the common core we have now? Here are some topics which are going to be in AS. If you're taking A-level maths, you don't have to study these in year 12, but if the class has some students taking AS maths, then you probably would. And here is some content which is no longer in AS maths. The first 3 topics are still in A-level maths. Some content has been introduced into the A-level. And some content has been removed. The amount of statistics in A-level maths is perhaps slightly more than in S1. There's a new approach to statistics. Students are expected to investigate a large real-world dataset during the course. It's likely that the exam boards will provide the dataset. Some of the exam questions will assume that students are familiar with the dataset and its context. You can think of this as being like a set text in English. A longish quote from the documentation tells you more on the next slide. You may have seen this quote earlier in the presentation. The mechanics content in A-level maths is perhaps slightly less than in M1. It will be the same for all exam boards. The content documents also refer to overarching themes. We imagine that there will be a stronger emphasis on these in the exam papers than currently. These quotes about technology are from the content documents. We don't know yet about the use of calculators in exams. Calculators that have the necessary features currently cost between £10 and £15. It's likely that their cost will come down. Further Maths is a completely separate qualification from Maths. Half of the content of the A-level is fixed for all exam boards, mostly pure maths. The rest will be options. For AS, up to 70% of the content will be options. There's more on the content later. The aim is that it should be possible to teach AS Maths and AS Further Maths in Year 12. It's actually quite hard to design AS Further Maths so that this is possible. The core content for A-level Further Maths is roughly equal in size to 3 current Further Pure units, but it's all assessed at the end of the course. For AS Further Maths, some pure topics will be the same for all specifications. The exam board chooses a bit more pure maths, and this leaves room for options. The optional topics in Further Maths can be more mechanics or statistics, or more pure maths. New applications can be offered. What about decision maths? That certainly won't be in maths, but something like it might appear in Further Maths as an option. Here is a quote from Alcab about decision maths. What can maths departments be doing now to prepare for September 2017? Perhaps you need to organise CPD so you have enough teachers who can teach mechanics and statistics now that they'll be compulsory. Are your colleagues confident in their use of spreadsheets and other technology? How committed is your department to teaching problem solving? You might want to look at the Cambridge Maths Education Project resources and CPD. As new A-levels in other subjects started in September 2015, at the same time as budgets were getting squeezed, schools and colleges have been making decisions about whether to offer AS levels and whether to offer fourth subjects. Although changes to maths and further maths are not coming in for a while, you may find that your school is already making decisions now which will affect maths and further maths in 2 years' time. Keep your eye on the MEI website. There'll be plenty of advice and support available for all specifications.